Hello and welcome to video lesson topic 11.4, where we are talking about how to find the volume of prisms and cylinders. And our learning objective is I am learning to find the volume of prisms and cylinders. This is pretty straightforward if you've already done topic 11.2, which I assume you have. I'm just going to give you a couple new formulas here that in my opinion are easier. So the volume of a prism, this one, is volume equals the area of the base times the height of the prism, aka altitude, as mentioned in 11.2. B is the area of one base. Remember, a base means that if you have a prism, for instance this triangular prism, the two sides of the prism that are congruent and parallel are called the base. That's what makes this triangular prism a triangular prism. Then we also have, I guess I should have put this down here, but volume is just like how much space something takes up. So I'll rewrite that formula here. And then the volume of a cylinder is going to be the exact same thing, except for, it would be the area of a base, but since a cylinder, its base is a circle, you could instead just abbreviate it like this, or not abbreviate, but write out the area of the base, since it's a circle, is pi r squared times h. So we're going to take a quick look at example 3 and example 4 today. Example 3 says in exercises 1 through 8, find the volume of each prism. So what you would do is find the area of the base. So for instance, if the bottom is the base here, the area would be 6 times 6, which is 36. And the height would be this distance between the two bases, the top and bottom, which is 6 feet. So then you would just multiply those and you get 216 feet squared. You do that exact same thing for B and C. So let's say that I did C. If the bottom is your base, then it would be capital B times H. 10 times 3, which is 30, and then the height is 6. So that is 180 meters squared, or cubed. Sorry, I should have put cubed here. So cubed because this is three-dimensional, it's actually taking up space. Area is squared because it's two-dimensional. Now you would repeat that process on D, E, and F, but these are triangular prisms. So let's say that we wanted to do E. Now it's hard to see on here, but you can see it on the PDF on Google Classroom, but there's tick marks here. And this side is 3 feet, this side is 3 feet, this side is 5 feet. If we wanted the area of the triangle, B, that'd be 1/2 times base times height of that triangle. And then the height would be the distance between the two bases, in this case the two triangles. So you multiply that by 5. So 9 times 5 is 45, divided by 2 is 22.5 feet squared, or cubed again. Keep messing it up, so used to squared. You could do that with part D here, but they don't give you the height of this triangle, so you'd have to do your 30, 60, 90 degree. I don't think I'm giving you any of those, so I'm going to skip it, but I will do F with you. So the area of the base would be the area of this triangle, and it is 1/2 times 12 times 20, and then the height would be the distance between the two bases, in this case 6. So you can plug all this in your calculator, or you could do it on your head. I'm going to plug it in the calculator. So 0.5 times 12 times 20 times 5 gives me 600 millimeters cubed. Got it right that time. Now for example 4, you have the same formula except the base is a circle. So instead of putting capital B, I'm going to put pi r squared, and then the height is just going to be the distance between the two circles. So as long as they give you the radius, you're good to go. In this case, the radius is 6, so pi times 6 squared, and then a height of, in this case, 8. Now there is one catch. They want you to get 2 answers. These answers are going to be equal, but they're going to look different. It says find the value in terms of pi and to the nearest tenth. So if we don't put pi into the calculator, this answer would be 288 inches cubed. Oh, I forgot my pi symbol. Or if we do put pi in the calculator, our second answer would be 980 or 904.8 inches cubed. Let's do that again. Part B, pi r squared times h. In this case, I believe they give us a diameter. Yep, they give us a diameter of 4. That would be a radius of 2, because radius is half the diameter. So you do like 2 squared times a height. So the distance between the circles here is 10. If we don't put pi into the calculator, we would get 40 pi centimeters cubed. And if we do put pi in the calculator, we will get 125.7 centimeters cubed. One last time. On part C, they give us a diameter of 5. So if we wanted the radius, it'd be half of that. And then the height here is 6. If we don't put pi into the calculator, it says it is 37.5 pi meters cubed. And if we do put pi into the calculator, it gives us 117.8 meters cubed.